Okay, I'm going to review finding the domain of a function and then add finding the range. Remember, domain has to do with the inputs. So domain is about the inputs, which is values of x. And the range is the output, or the values of y. So let's look at the function f of x equals the square root of x plus 3. And remember that that number, x plus 3, has got to be a 0 or positive. It can't be a negative number. So we can still do this algebraically. We can just say x plus 3 has to be greater than or equal to 0, which means x has to be greater than or equal to a negative 3. So that's my domain. Remember, we also wrote in interval notation, we said inclusive from negative 3 to infinity. Right? And we can verify that graphically. So here's the function. I typed it in Desmos, and we realize that there's a solid circle there. So the point negative 3, 0 is on our graph, right? But there are no values that have an x coordinate of anything less than negative 3. So there's nothing that way on the graph, right? But we can see, or see from this graph, that that's basically going to go off to infinity. Right, so now let's look at the graph and say, what are the possible outputs for y? Right? And as I look at this, all right, here's my y-axis. It looks to me like y can be any positive number, including 0, but I never see any points that are below the x-axis, so never have a y that is negative. So when I talk about range, I can say y has to be greater than equal to 0, or in interval notation, we are inclusive from 0 all the way to infinity. Good? Next problem, square root of x over x minus 5. Remember, when we're looking at a fraction, we're only concerned that the denominator has to be not equal to 0. So x minus 5 cannot equal to 0. And then if we have a square root, we just have to look at that x, and x has to be greater than or equal to 0. So we've got two restrictions on our domain. I can solve this problem. So x cannot be 5, and x cannot be 0. So once again, you can work on the notation there. All right. So that's our range. In fact, let me finish the notation. So we can go from 0. We can see it from our graph over here. Inclusive, so x can be 0, all the way up to 5, but it can't be 5, union, all the way from 5, not included, all the way to positive infinity. And we see that. We see that these parts of the graph looks like it just climbs forever and goes down forever, but never actually crosses where the input is 5. It's not on our graph. And then you can see all the x values goes on forever this way, and you've got no negative values for x, so there's nothing that way. All right, so now let's look at range. Once again, just interpret it from the graph. And really, what you have to convince yourself of here is that that point has a y coordinate of 0, and this looks like it goes down forever to negative infinity. And this number, really close to 0, all but touching, and it get infinitely close. And this is going to go up to positive infinity. So I still think for my range here is still all real numbers. There's no restrictions on the range. Okay, one more we'll look at. F of x equals 2 over x. So once again, my restriction for my domain is x cannot equal 0. And we see here that from the graph we can verify that. It looks like that part of the graph increases, up to infinity, negative infinity, and then the x values were what we should be worried about. That goes all the way to infinity, and that goes to negative infinity. However, I never have any point on this graph whose x-coordinate is 0. Looking at it even further, I don't think there's a point on here where the y-coordinate is 0. Remember, this is the y-axis, all right? And once again, I think the graph increases forever and gets closer and closer to the y-axis, but never crosses it, and that's closer and closer also, and never crosses it. Same thing here. So we never get an output of 0. So my range, so my domain is all numbers except 0. But I think my range is the same thing. Y not equal 0. Or if we had to write that each of those in interval notation, we'd say negative infinity all the way to 0, not inclusive, and then from 0, not inclusive, all the way to positive infinity.